Clear?
Yeah.
Okay.
Doctor,
Yeah.
can in previous exercise
Mm-hmm.
there's a conductor, the specific conductor that we need to refer on the table in appendix.
Yes.
So is that table will be provided?
In the test, most probably because I'm not, I'm not done with the question yet. Most probably I will pick a conductor. I'll pick conductor and put the details in the question. Don't worry.
Yeah, thank you, Doctor.
Any more question? Any more question, class? Hmm? No question. I can hear it going. So any other question? No.
No.
Okay then. So we have seen how to do the Y bars, Z bars, and then we already know the type of line that we have: short, long, medium. For short line, we consider until what kilometer? For short line,
80,
huh?
80 kilometer.
Come again? Not clear.
80.
80. For medium, for medium line,
80 kilometer to 200.
80 to
250.
150. And then for the long line, more than, huh? Shariza?
More than 250.
Okay then. So we know that we have a network, right? In order to transmit, we have generation part, we have the transmission part, and then we have the distribution part, right? So the whole thing we name it as a system, right? Hello? Huh? The whole system we name the whole power what the whole the complete system that we develop to transmit the power, we call it a power system, right? So before this, we know that we have to deal with buses, right? Class, we deal with the buses, right?
Yes.
Okay, so in order to transmit, okay, from the generator, from generation, it will go to the one bus, and then one bus, then to transmit to other bus, right? To other bus in the system until it goes to the consumer. Understand? Okay, so in the bus system itself, we have several type of bus. Okay, first we name it as a slack bus. You need to know this, eh? First, we name it as a slack bus, or we call it a slack or swing bus. And then we take it as a reference bus. Slack bus is a reference bus. Okay. Boleh? Hello? Okay, that's good. I can see thumbs up from Shami. So slack bus or the reference bus, and then the load buses. Okay, load buses, we call it PQ buses, and then the regulated buses, where you consider as the generator buses, or we call it as the voltage control buses. And also we call it as the PV buses. So we have slack bus, we have PQ bus, and then we have PV bus, whereby the slack bus is the reference bus, load buses for PQ buses, and then regulated buses, we call it PV buses. Any questions here? Any questions? Okay. Boleh Okay. Remember this. Okay. And then, what is this? What is this, class? This is the
Line diagram.
line diagram, single line diagram, whereby we know that this is the currents coming in. Okay, so this is the this is the line, and then this is the, what is this? What's this?
Admitted.
The reference. Okay, the reference admittance, we ground it. Okay, so this is the power flow equation. This is the power flow equation. Whereby I equals to V and the admittance. The total of bus. This is the bus. Okay. Boleh?
Boleh tak, Ustaz?
Faham this equation? This equation referring to this diagram. Boleh?
Tak faham.
Come on. You try, later on.
Doktor,
Yeah?
Doktor, if based on this figure, mana satu slack bus, load bus and regulated bus?
Yang ni belum lagi. This is the only the basic power flow equation. Nanti kita tengok ya. Basically, yeah, you just mention the buses je. And then how do we calculate current at each bus? Okay, current at each bus, and then we sum up. Kan? Sekejap saya buka lampu. Okay. I think it's going to pour quite heavy rain. Okay. So this is the real and reactive bus at bus I. So Pi plus JQi equals to Vi conjugate. This is at bus I. Bus I, and then we can get the I. Okay, then we got the PQ and V with this total of apa ni? The current, right? Current from the previous slide. Understand? Can you see that from here? From this line, we get this equation. Understand? And then from P plus JQ, we got this one. And then this is equals to this one. Boleh?
Boleh, Doktor.
Okay, so stated here that from the above relation, the mathematical formulation of the power flow problems results in a system of algebraic nonlinear equation which must be solved by iterative equation technique. What is iterative techniques, class?
Iterative technique.
Huh? What is iterative techniques? Basically, this is the iterative technique whereby you need to calculate one by one, one bias to one bias to one bias. Understand?
Okay.
Boleh? Okay, for this topic, I would like you to have Hadis Sadat's book. Do you have Hadis Sadat's book with you?
No, Doctor.
Okay, I'll share through Putra Plus later on. Please remind me,
Okay,
yeah?
Doctor.
Please remind me.
Okay.
Because from the books, you can see how can you solve this using MATLAB. For this topic, I want you to play with MATLAB. Okay? Get familiar with MATLAB software. Boleh?
Boleh.
Eh?
Boleh, Doctor.
Oh, sorry. Tak apalah ya. Okay, so there are several solutions to solve the power flow. Okay, this is the basic. This is the general one. Yeah, this is the general one to solve. But in order to do the iterative technique, there are several iterative techniques that you can use. First, researcher come up with Gauss-Seidel method. The first iterative method is called Gauss-Seidel method. Okay, so this is the Gauss-Seidel method. Okay, starting from here, VPQ. Okay. Any question here?
Can I share the book now?
Come again?
Can I share the book now? I have the book.
Oh, you have the book with you. Okay. Boleh?
Share in the WhatsApp group.
Okay. So this is for baby buses. Okay. What I want you to do now is, let us try one example. Let us do together. Is it possible, class? Boleh tak?
Yes, Doctor.
Okay, you start first. We have here this system. Bus 1 is the slack bus. This is the slack bus or the reference bus. And then this is the parameter for the slack bus, P1. And then bus 2, we have this load. This is the load bus. Okay. Load bus, stating that they have the 280 megawatt plus J60 MVR. So what is this, class? This is
B.
P. And then this is JQ.
Q.
Okay. Okay. So try using Gauss-Seidel method. Using Gauss-Seidel method, meaning that we need to make use of this equation. This equation. And then instead here need to perform 4 iterations. Anybody would like to show me? Write down and snap a photo. What is the first step? Before you go details. What is the first step? When you get this diagram, so what is the first step, class? Hello? Anybody with me?
Yes, sir.
Okay, what is the first step?
Tak tahu.
Tak tahu? You say this is the what
Oh,
is this?
change to admittance.
Change it to the admittance. Change it to Y. And then this one, you need to change it to change it the hello.
Phasor form.
Phasor, no. Change to the per unit. Because everything is here in per unit, so you need to change it per unit. See? First, we find the Y, right? And then we change it to the per unit. PU. Because everything are in per unit. PU.
Kena bagi 100 lah doktor.
Yelah, sebab apa kita bagi 100? Why do we divide by 100? Because it stayed here, right?
Oh,
Ha. Okay. So starting with an initial estimate, this one given, kan? This one given. Ni given. And then you perform 4 iteration. Any question, class? Sedang buat? What is this referring to, class? This one.
Number of iteration.
Yes, number of iteration, pandai. So we start from 0, okay? So initial estimate is 1.0 plus this one, voltage plus 2. And then this is from here, right? Kan? Plus.
Ya doktor.
So kenapa campur? Why this is plus?
Conjugate kot.
Conjugate code. This is cannot code.
Sebab formula
Be sure. See?
formula ni.
Yeah.
refer back to the formula. Okay. I think something is wrong here. Apa tak? Apa tak? Apa salah kat sini?
10J20.
10 nanti betulkan
Hmm.
It should be 10.
29.
Ya, dia 29. Kita clear balik
Doktor, dekat formula tu apa maksud? Yang J equal to 1 tu.
Apa maksud?
Yang formula Gauss.
Formula Gauss-Seidel. Yang mana ini?
Yang J equal to 1.
J equals to 1 ni.
Yang bawah tu J equal to 0.
This one is from the next iteration. Maksudnya the first one. It start from 1, but then this one from the previous one. Okay, as an example, sini, kan? Sini, it will be Y. It can be I, can be what? I can be 1, let's say 1 plus 1 lah, or 0. 1 lah, 1. Y, 1, 1, B, start with B1. But then from here, you can start from Y, 1, J, 0. So this one, what is this? What is representing for this one? Ini adalah, ni kan? Dia campur. Sorry. Cuba tengok balik. Try to put the equation next to it. What is this?
Voltage.
Voltage. So try to put it back, the equation here. So this will be Y12, right? Cuba letak balik sebelah dia. Mari tengok lagi lah. Anybody would like to show me any your solution? Just snap it. Start from the general equation, and you can see. Anybody would like to share with us? Harisa?
Ya, saya doktor.
Tak.
Tak okey.
Ah? Apa?
Tak okey. Sekejap.
Kat mana tak okey?
Lagi tengah kira sebenarnya. Yang one iteration tu dah, yang second and third.
Oh, okey. Tunjuk dulu yang first. Start dengan general equation. Please start with the general equation.
Doktor guna textbook mana doktor? Saya check 3 textbook tak sama pun.
Tiga textbook tak sama?
Sebab tajuk 6.6 kan. Saya tengok buku yang Hadi tu lain. Lepas tu buku yang warna biru tu pun lain.
Saya ambil mana? Saya pun tak tahu saya ambil mana. Sebab dia ikut nota lama.
Doktor.
Enam betul lah. Betul lah. Sekejap 1186. Sekejap saya check.
Oh, problem doktor. Okey. Banyakkan example. Sekejap.
Janganlah tengok tu, tengok ni dulu. Bagi tunjuk dulu. Anybody has tried? Siapa lagi saya nak sebut? Arisha?
Ya, saya doktor.
Dah buat dah?
Sedang.
Lambat sangat. Show me the first one. Show me the first iteration.
Wait.
Syami,
Ya, doktor.
ada tak? Dah buat tak?
Bukan macam sama je ke yang doktor tunjuk ni kalau saya boleh jawapan saya.
Tapi saya nak tengok.
Oh, okay.
Just share with us. Just share with us. Lambatnya. I would like to see the first iteration. The first one. Nobody would like to share. Nobody would like to share. Tak nak share ke? Okay lah, maybe later on we do the exercise, then you can understand it clear. Boleh?
Boleh doktor.
Kenapa sedih sangat ni semua? So basically, this is the our main target is to get to determine the line loss. Okay. What does it mean by converge, class? What does it mean by converge here?
Expand. Expand.
I can't hear you. Nazrul, tak dengar.
Expand. Doktor.
Extend,
Expand.
expand. No, you see from here, okay, from the iteration, at some point it will converge, mean that it will give the same answer at some point. And then that's what we call it converge. We name it yesterday. It will converge. Okay. So when it converge, it said that V2 equals to 0.9 minus J 0.1. Okay. So then we calculate the I based on this value. Okay. So we got the S. This is the apparent power for bus 2-1. Okay, this is the apparent power. And then we try to calculate the line loss. Okay, line loss between the first S12 and S21. Then we get this one. This is the line loss. The losses. Okay.
Doktor, kenapa V1 tolak V2?
Kenapa V1 tolak V2? Kenapa V1 tolak V2 kelas?
Dekat line.
Dekat line. So we would like to find the, what is this? Y12 V1 minus V2. The current, right?
Yes. On the first picture.
Current. So this is the current from bus 1 to bus 2 kan? So this will be the Y, right? So the 1 and 2 kan? So the 1. Betul?
Yes.
Faham?
Faham ke?
Faham.
Okay. So you know, from this, what can you say? It's relates, right? From A to B. You need to solve A in order to solve B. Can? You need to find this V2, basically. So you need to pass the first question. The first question you need to pass, and then you can solve the B question. Because B question make use of the A answer, basically. So if you fail to solve the first question, what will happen?
There will be no marks for B. You cannot answer B.
Pandai. Okay. So remember, the main here is to find the line loss. Faham?
Faham betul.
Faham Kat mana yang faham? Oh, faham apa?
Faham cara nak kira sikit-sikit.
Sikit-sikit.
Ha.
Bagus. Senang je. Basically, V equals to IR kan? So, this one I equals to YV. Dia base dia adalah V equals to I R je. So, let us consider. Let us consider this bus. This is, we have slack bus. This is what bus? This is slack bus. This is? What bus is this, class? Hello?
Regulated.
Yes, this is a regulated bus. And then this is the?
Dot
This is
bus.
the?
Dot bus.
Okay, pandai. So from here we can see everything's are in per unit. No, this one is not in per unit. And this is not in per unit. Okay, so this one is the example. Okay, whereby we have the line. We have the line admittance. And then we convert the load to the per unit. And then this one, bus 1 is taken a reference bus as we said earlier. And then this is okay, this is the first iteration. The first iteration. Okay. And then this is for the regulated bus. Okay. This is one we saw for V regulated, sorry, V control, cell control or regulated control for the control bus. Then we got the E for the first iteration. This is for the first iteration, yeah. When we consider the regulated bus, will be quite complex because we need to consider the Q part. Okay. This is the second iteration. So this one, they iterate until it's converged. Till it converge, you see? Until it converge. Then we got the final solution, the S. See, I said the main is to find the line flow and the line loss.
Doktor,
Yeah,
simbol yang kerja dekat Q tu apa?
simbol yang kronik kat Q.
Formula Q tu. Yang keli depan tu.
Okay,
Tu apa?
agak-agak apa ni? What is this, class?
Tak tahu doktor.
Tu mana tak tahu ni?
Macam pelik ni semua.
Ah,
First time nampak.
first time nampak?
Sebab dalam buku ni kot doktor.
Apa dia?
Maybe sebab dalam buku ni kot.
Sebab dalam buku tu actually dah total je. Sekejap. Kejap ya. Dekat sini tak? Untuk QBus. PV bus. Ni untuk QBus. Ini kan R. Ini dia punya imaginary. Dia punya imaginary lah, imaginary symbol. This one is real. This one is imaginary. Itu je.
Doktor, yang V2 tu kenapa kena tambah Y23?
Yang ni. Yang ni.
Sebab yang first tadi 1, 2 je kan?
Satu yang itu kita tak consider dia punya V3 kan. Dia punya voltage regulated bus. Kita cuma ada slack bus dan juga load bus sahaja. Cuba tengok balik tadi.
Yang salah first.
Yang ni kan? Yang tadi kan? So itu cuma ada dua je. Ada the slack bus and dia punya load bus tu sahaja.
Jadi regulated.
This one dah dia kena ada sebab dia start pun dah ada 3 bus. Faham tak? This is for first saturation. Dia kena consider juga. Okay. Any other question? Nak try dulu ke macam mana? Would you like to try first or what? Okay, at the end, this should be your answer. This should be your answer. What does this mean? What does it mean?
Supply.
Supply. Supply.
Flow in. Flow in through.
What is this?
Real power.
Yes, this is the P and then this the Q. So this one is P, this one is Q, right? Cuba cek balik. Kan cuba tengok sini. The S is P, kan? Cuba tengok. Okay, say that real power is given by this one. Reactive power given by this. Okay, ini P and Q lah kan? So this is the P and Q. This is the Y, kan? So this will be the what that you need to come out lah later on by end of by solving those equation. Boleh? In the normal class, we solve this together. Okay? Boleh class? Before we proceed to next method.
Boleh doktor.
Okay. Sure, eh? So from that coside it's quite complex if we deal with too many buses. Okay, that's why another researcher come up with another solution where they call it Newton-Raphson power flow solution. It's actually the improve from the Gauss-Seidel method. So Newton-Raphson, whereby this is the general equation for the Newton-Raphson. It is a normal equation, right? This one B. This one also you already seen it. This one also. This is okay. From Hadi-Sadat's book, you can see the evolution from Gauss-Seidel, Newton-Raphson, and so forth. So the Newton-Raphson, we deal with the matrix system, okay? Whereby we know that the difference of P and then difference of Q, we we name it as J1, J2, J3, and J4. This is meaning that the Jacobian. This is the Jacobian matrix. Convert it into the Jacobian matrix. And then we got this equation. This is the Newton-Raphson equation. The diagonal and off diagonal. Okay, so this is how we do. How do we solve this? And by end of the day, we would like to have this. Okay, the power residuals. Okay. This is the procedure for the Newton-Raphson loop flow equation. You need to know this. What would you say if we try to solve the Gauss-Seidel method first? Is it okay? Because
Yes, doctor. I agree.
okay, you try to solve the Gauss-Seidel method first. Let us see. You go to the problem. You have the books with you, can? Go straight to the problem. Or maybe you can solve the example first. Example, I already solved it for you. Okay, example done. Just now, which example that we do? Okay, class. Try to solve example 6.7 first. Try to solve 6.7. Okay. Try to solve example 6.7 and then try to do problem 6.7 and 6.8. Can you get that?
Yes, Doctor.
Okay. And try to solve try to answer the question regarding apa tu? To use the MATLAB. Okay, like for example, problem 6.7, problem C. Okay, problem C, it said that check the power flow solution using IF Gauss and other required programs, meaning that you just use a MATLAB program. Boleh? Clear tak? Is it clear, class?
Yeah, Doctor.
Okay, try this first. Okay, if you have anything, you can always contact me. And then submit by Friday. Boleh? Boleh, kelas?
Boleh,
Dr.
Doctor.
Ah?
Dr. Sunday boleh?
Sunday?
Got test today.
Got test?
Until
Okay lah, Sunday. As long as before you come to class on Monday. Because Monday we like to proceed straight to the Newton-Raphson methods. But in order to understand Newton-Raphson method, you need to understand the Gauss-Seidel method first. Faham?
Faham.
That's why I want you to master it first before we proceed to the Gauss-Seidel method.
Boleh Dr.
Boleh eh? So any question, class? Hello? Dah diam dah. Dah hilang dah semua.
Setakat ni tak ada. Okay.
Boleh tak tunjuk ke saya? Can you show me for this question? Anybody has done it? For this question. For this question. Let me see. Siapa dah buat? Tak siapa buat ke? Belum sedihnya saya. Levin, Raj.
Doctor,
Yes. Have you done this?
I haven't Doctor.
Have you tried this?
I haven't Doctor.
Haven't?
Haven't Doctor. Sorry. After this I will try.
Huh?
After this I will try. I have to understand properly everything Doctor. Then I will try.
Class, there is a reason why I upload these notes earlier. What is the reason? What is the main reason? Yes, because it's hard for us. It's hard for me to teach. That's why I want you to read first, try it first, then we can discuss. Understand or not?
Yes.
because it's related with heavy calculation for this subject. That's why you need to understand it before you come into the class. Or else I'll be talking to myself. Huh?
Sorry, doctor.
None of you try this. No, I mean, after I did ask you to do it, right? Just a minute ago, right? Anybody try?
Doktor, saya try buat yang first iteration saja.
Yang first generation, just show us. Just show us.
Nak show macam mana pakai WhatsApp ke?
Boleh lah pakai WhatsApp and then explain.
Okay.
Show dekat WhatsApp. Why don't you start with the general equation so that you can understand? I want all of you to start with the general equation first.
Okay, doktor.
Boleh Macam V ni, you cannot simply just put V2 blah 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 blah. Okay? You cannot just put like this. You need to start with the general equation. In the test, maybe you can just straight away, but then in the exercise, please start with the general equation. Basically, if you start general equation, you won't get wrong lah. Faham? Start with general equation. Okay. Okay. Remember, start with general equation, and then remember the unit. The unit you need to spell out. You need to write out. The unit, whether it's per unit, whether it's the megawatt, whether it's the var, current, ampere. Okay? Jangan lupa ya. So I think I'll stop here lah ya. Let you digest the Gauss Seidel method first before we go to the nature absent methods. And then regarding the test tomorrow, Wednesday's test, as I said earlier, we're going to have 4 questions. At the admittance, the Y matrix buses, the Z bus, okay, Y, Z, and then the conductor, to calculate the conductor, and then the line parameter. Okay. Boleh?
Boleh.
Okay. Any other question? Any other question? And then don't forget the attendance. Zara dah buat attendance?
Dah lah, saya dah bagi dalam.
Okay, thank you. Thank you so much. So, any other question? Narrators. So I think if no question, we stop right here lah, yeah. If you have anything you want to know, anything you want to ask, you can just text me, okay? So I guess we adjourn our meeting now. Then I'll see you on Wednesday.
Thank you, Dot.
Thank you, Doctor.
Thank you everyone for joining.
Thank you. Assalamualaikum.
Thank you, Doctor.